Now the next numerical based on the superposition principle. Suppose we are having two charges. One is suppose 1 microcoulomb, another one is suppose 16 microcoulomb, minus 16 microcoulomb suppose, and the separation is suppose 30 centimeter. Okay, so the question is same, where we have to place a third charge such that the net force on the third charge will be 0. That means it will experience no force. Okay, so suddenly suppose if you place the third charge here, q plus q, then what will happen? This is plus, so it will repel, but this is minus, this is plus, so attract. That means two forces will be the same direction, and if two forces in the same direction, then they cannot produce the zero resultant force. Okay, so that means the charge must not be placed in between. So then where we have to place the charge? Where we have to place the charge? Either we have to place the charge in this side or in this side. Now in this side it is not possible, because if you place a charge here, third charge, so this 16 is much more than 1, and so therefore the magnitude, product of the magnitude will be more. So this charge will experience a tremendous force. Similarly, the distance will be less, and distance is inversely proportional to the force. So less the distance means more the force. So that means due to 16 the force will be tremendous, and due to 1 its magnitude is less, so the force will be less, and its distance will be more, so the force will be much more less. So therefore here due to 16 the force will be maximum, and due to the plus 1 the force will be minimum, so they cannot produce the equilibrium or the zero net force. So therefore the charge should be placed on this side of this 1 coulomb. Let this distance be x. So due to this side the force due to this one is magnitude is less, but the distance is less, so the force will be more, and its distance is more, so due to the 16 force will be less. So therefore what is the net force? Due to minus 16 it will be attractive F1, and due to plus 1 and plus q the force is repulsive F2. So therefore what is F1? Let us find out. F1 will be equal to, let us directly substitute, F1 will be equal to 1 by 4 pi epsilon 0 into q into 16 by 30 plus x square is equal to, see, we don't have to consider this minus again, because we are considering minus in the diagram. Because of minus this force is attractive. Okay, we have already considered, so we don't have to consider again. Clear? And due to this plus 1 coulomb, what will happen? The force will be repulsive, so it will be 1 by 4 pi epsilon naught into q into 1, 16 into 10 to the minus 6, 1 into 10 to the minus 6 divided by this distance will be x square. So therefore 1 by 4 pi epsilon naught q minus 6 cancel out, so it will be 16 by 30 plus x square will be equal to 1 by x square. Now this 16 can be replaced by 4 square. So therefore we can write 4 by 30 plus x will be equal to 1 by x. So therefore 4x will be equal to 30 plus x. That means 3x will be equal to 30. So x will be equal to 10 centimeter. That means the charge has to be placed 10 centimeter on this side.